let's take a look at lesson 6.6, volume of 3D shapes. Once again, we're going to be following a very similar process where we identify the shape, label it, figure out which formula we need, we sub in the values and solve, and then we write our conclusion with any units. You're going to use this process a lot in math and science, where we identify the type of problem, make a diagram, add any labels, figure out the equation that connects our variables, plug in our values, solve, and write an equation. So if you just memorize this process, and there's a similar process in science you might use called GRESA, where you look at the information that's given, you look at the information that's required, you figure out which equation you need, you solve, and then you write your answer. As long as you're able to use this process and get used to it, you'll be able to do most of math and science class. The problem is this process is better for straightforward questions like find the area, find the perimeter. It's important that in math you're not just memorizing, but you should try to have an understanding of what's going on. So if we had more time in this course, if we were in the classroom, I would have tried to explain to you more about how these equations work. So we have a formula sheet with all these equations for volume and surface area, and I'd love to break it down and talk to you more about how do they come up with this equation, and how come these equations are slightly different even though the shapes are similar, and things like that. Unfortunately, we don't have a lot of time with how things have gone this semester. So I'm going to teach you how to use the formulas, and hopefully in the future in grade 10 math or wherever else, you'll have more time to dig a little bit deeper and understand what the formulas mean and how they've come up with these parts. But as I mentioned, if you can at least follow this process, if you at least have a formula sheet where you can identify this is the shape I need to find volume, or I need to find surface area, I can at least teach you how to identify and use the formulas. Just know that there is more to math than just memorizing formulas, and hopefully in the future you have the opportunity to dig a little deeper into this. But given our circumstances, we're just going to do the best that we can. All right, so we're going to take a look at the homework from Unit 6, Lesson 6, and let's dive right into 1A. All right, for 1A, we are asked to determine the volume of each solid. We have a rectangular prism here where the height is 15, the width is 20, and the length is 12, and they're all in centimeters. You should put the centimeters after the numbers. It's just harder for me because I'm working with the marker. I don't want to smear my picture and stuff, so I've written it off to the side so it's still written somewhere. So what shape are we working with? Even if you don't know the name, so hopefully you recognize this as a rectangular prism. Otherwise, just look at your sheet and identify which shape matches. So we have a rectangular prism and we have our labels. Length is kind of like the front to back measurement. So this 12 is going to be our length. Width is how wide it is across the front. So let's label that with a W. And height is the up and down. So H for height. So we have our shape. We have our labels. Let's find our equation and let's sub and solve. This question asks us to find volume. So volume for rectangular prism is volume equals length times width times height. And as I mentioned before, I just used the cursive L, so you know that it's an L and not like a 1 or something. Let's plug in our numbers. Let's sub them in. Length was 12, width was 20, and height was 15. Also, just a quick reminder, if I just use the brackets, that just means multiply. I could write 12 times 20 times 15, but we already have so many letters, I don't want you to get confused and think my multiplication symbol is an X. So let's just do our math. We've subbed. Let's do the solve part. 12 times 20 times 15 is 3,600, and that's all we had to do. Let's just state our units. 3,600 centimeters. And remember, for volume, you should have seen this in the other YouTube videos already, volume is cubed. Please be careful. When we're dealing with perimeter, I would have centimeters because it's just a length. When dealing with area, I have centimeters cubed. So imagine I have flat little centimeter squares I use to fill up the space. Now we're dealing with 3 dimensions. So for volume, it's centimeters cubed. Just think about this as the number of dimensions. This measures like a string. A string only has 1 dimension, length. This measures things like squares. Squares have 2 dimensions, length and width. And now we're dealing with a volume. 3D figures have length and width and height. So this tells you the number of dimensions. So please be careful and make sure you're using the correct units. So that's all we had to do here. We subbed and solved and conclude. Therefore, volume is 3,600 centimeters cubed. And honestly, this wasn't a word problem. We could have just left it at this, and that would have been all right. Let's take a look at 1E. In this case, I'm dealing with a cone. So let's take a look. And what do we have for cone? Well, we have a couple labels. We have the height. In this case, this is on its side, but that's okay. I'm just going to kind of write this off to the sides. Well, I'll just use a different color. So our height is this is from the middle of the base up to the tip. So that's going to be our height. Next, we have our radius. So the base of a cone is just a circle. And so the radius is going to be from here to here. And we're given the diameter. We know the whole thing across is 20, so just the radius is going to be 10. I'm just going to write that in right away. And I need one more measurement. I need this L right here. And that is called the slant height. So this length right here. So we're going to call that L, and that's going to be a slant height. Notice that in this case, we don't know what that is, and we're going to need it. Actually, we don't need it. We need it for the perimeter or for the surface area, but in this case, if we look at our formula for finding volume, volume is pi r squared h over 3. I need the radius, which I have. I need the height, which I have. I don't need to worry about the slant height. But just so you know, that's what that means. This is called slant height. This question only asked us to find the volume, though, so let's go ahead. We identified our shape already. We already added our labels, the H and the R, and we added the L, which we didn't end up needing, but that's okay. And now we've talked about it. Let's sub and solve. We have our equation. Let's plug in our values. Remember, pi is just a number. Don't try to solve for pi. And it kind of looks like an X or something. It's not. It's a number. Radius is, we just said it was 10. Be careful here. This is the diameter. Don't plug 20 into your equation. And r squared, because like 2 radiuses is the diameter. That's radius plus radius. So 2 times the radius is the diameter, not radius squared equals diameter. So be careful. Radius squared means take the radius, which is 10, and then square it. And the height we have here is 22 divided by 3. Once again, you can plug this all in your calculator all at once, but be careful. It's easy to make typos. I'm just going to do the top first, and then I'll do the bottom. Pi times 10 squared times 22. So my top number is 6911.50 over 3. Volume is 2,303.8. What were my units? Millimeters. And it's volume, so it's cubed. All right, that looks pretty good. Let's double check our answer. The answer key 1E, we should have 2,304 millimeters cubed. All right, they rounded to the nearest whole number. I rounded to the nearest tenth. That's okay. But once again, we subbed and solved, and we concluded with our units. Looks pretty good. Let's try another one. Once again, we are asked to determine the volume of each solid. And what shape do we have here? It doesn't really match with any of the shapes I have on my sheet, but I kind of look close to this one. So what we have here is half a sphere. So like we've taken like a basketball and sliced it in half. And this is just the bottom half, so kind of like a bowl. So what we're going to do is we're going to use the equation for a sphere, but then we're going to divide our answer by 2. So let's imagine this is a whole sphere. Let's calculate, and then let's divide. Let's take a look. So we figured out our shape. Let's add our labels. Which thing do we measure or label on a sphere? Just the radius. And we're given that. So this value right here is our radius. Let's sub and solve. What's our equation for volume of a sphere? Volume of a sphere. Volume is 4 times pi times radius cubed over 3. 4 pi, my radius is 18, cubed over 3. Let's plug that in our calculator and solve. 4 times pi, 18 to the power of 3. Your calculators might not have a to the power of 3 button, but you can write it like this. So it's like 1, and then the 8, and then the caret symbol, and then the 3. Or some of you might look a little bit differently. You might have like a x to the power of y button or something like that, and then to the power of 3. So I did that, and then divide by 3. So I'm getting 2, 4. I'm going to round to the nearest whole number here. My units were in millimeters and cubed, and there we go. That's it. Subbed in my values, solved, and concluded with units. You might notice that we're getting pretty big numbers with volume. That's normal. Volumes grow very quickly. So like they're growing at a cubic rate. So it's like imagine, just understand that they grow quickly. I don't want to overcomplicate it and over-explain it. It's normal to have big numbers for your volumes. For our next example, we'll look at 3D. Determine the volume of each composite 3D shape. It's going to be same as before. How did we deal with composite shapes before? Well, we tried to break it down into the basic shapes that are being added together to make that composite shape. So what are we going to have here? Oh, I just realized I made a mistake on the previous question. Let's go back to that for a moment. In the previous question, I made a mistake. We calculated the volume for the whole sphere, but we needed the volume for half of the sphere. I forgot to cut it in half. So for your final step, we're going to divide by 2. So the volume of the half sphere should be 12,214.5 millimeters cubed. So be careful with that. I just made that mistake. It's an easy mistake that you can make as well. The formulas given on the sheet are for the entire shape. When I need to cut it in half or a quarter or whatever, I need to divide my answer at the end. So please watch out for that. Let's jump back to 3D. What are the shapes we're going to deal with here? The top half is going to be a half sphere, just like in the previous question, and hopefully I remember to actually find the half this time. And my bottom part here is going to be a cone. So let's work with those shapes. And I'm going to label them just like I talked about before with composite shapes, just to help me keep track of what I'm doing. Let's call our top part A and my bottom part B. Let's find the volume of part A. We're going to have half of the equation for volume of a sphere, 4 pi r squared over 3. Half, because half a sphere, 4 pi. What's my radius? It's given right here, 3.5 centimeters, so 3.5 cubed divided by, actually that can stick out front, divided by 3. And we can do this all in our calculator. I don't have room to show all my work, but you can do this one piece at a time, and I'll kind of show it on the calculator. So 4 times pi times 3.5 to the power of 3 divided by 3 times half. The volume of part A is 89.8. What are my units? Centimeters, and it's volume, so it's cubed. Looks good. Let's find our volume for part B, the cone. So it's an entire cone. I don't need to cut it in half or anything. Look at my sheet. Volume of a cone is pi r squared h over 3. So pi, do I know the radius of a cone? Yes, that's our value right here. That's my r value. So 3.5 squared. Do I know the height? Yes, height is this number here. You can also see it labeled on our sheet here. So height is 10 divided by 3. So plug that into my calculator. Pi times 3.5 squared times 10 divided by 3. Volume of B is 128.3 centimeters cubed. Let's find the volume of our composite shape. The volume of our composite, we're going to add up all the parts. So volume of A plus volume of B. So 89.8 plus 128.3 gives me, plus 89.8, 218 centimeters cubed. Let's check our answer key, which I should have done last time. I would have caught my mistake earlier. 3D, our answer should be 218 centimeters cubed. Looks good. So we identified our shapes. It was composite, so we split it up and did 2 processes. We labeled as needed. This was my radius. This was my height. We also did our A and B labels for our separate shapes. Sub and solve, I figured out which equations I needed. I plugged in my numbers. I solved. Because it's composite, I added them back together. Remember, sometimes we will need to subtract them if we're doing a cutout, we're moving. But in this case, we're adding half a sphere to a cone, and then concluding with my units. Next, let's take a look at number 6. A square-based pyramid has a base with side lengths of 20 centimeters, and the volume is 4,800 centimeters cubed. What is the height of the pyramid? We're going to basically use our process again, but we're going to kind of add that step 0 that I've used previously. And step 0 is where we start by drawing a diagram to describe our word problem. So I'm going to sketch my diagram, then we'll identify our shape and our formula and stuff and go from there. All right, so I've drawn my sketch. We have a pyramid with a square base, so square on the bottom. I've used the little dashes to indicate that all the sides are the same length, and I know that those sides have a length of 20 centimeters. I've also labeled the height. So height goes straight up and down from the tip of the pyramid to the middle of the base. It's not the length of the sides. That's like a slant height. Once again, we don't want that here. We want the actual straight vertical height. And we're also given the volume, 4,800 centimeters cubed. Cubed. All right, so we've kind of done our step 0, which is to draw our diagram. We know what shape we're looking at. We have the labels. We have a side. And we have the height. Let's find our formula for volume of a square-based pyramid. Square-based pyramid volume is going to be volume equals A H over 3. But Mr. Strike, we don't have an A anywhere. You're right. The A here represents the area of the base of the pyramid. So let's kind of label that here. Pyramid base area. And let's start off our question by figuring out what that is. What shape is the base of our pyramid? Well, it said right in the question it's a square. So area is equal to, for a square, side times side, or side squared. I know that number, so I can plug it in. 20 squared. 20 squared is going to be 400 centimeters squared. All right, I know my A value. That looks good. Let's take a look at our equation carefully, though. I already know the volume. In this case, the question asked us to figure out what is the height. So I already have the correct formula. I got it from the sheet, but I'm not trying to find volume this time. I'm trying to find height. That means I'm going to need to rearrange this equation to get height by itself. We're going to rearrange first, and then we're going to plug our numbers in. So I know I'm just going to rewrite V equals A times H over 3. I want to begin to get the H by itself. Right now it's being divided by 3, so I'm going to multiply each side of my equation by 3. 3V equals A times H. Now H is being multiplied by A, so I'm going to divide each side by A. So 3V over A equals H. Now we can plug our values in. H equals 3 times V, which we're given up here, 4,800, divided by the A, which we just found out was 400. Let's use our calculator. 3 times 4,800 divided by 400 gives us a height of 36. And it is a word problem, so let's have a word answer. Therefore, pyramid height is 36. And don't forget our units, centimeters. And height is just a one-dimensional length. So it's not cubed, it's not squared, it's just centimeters. Let's double check our answer key. 36 centimeters looks good. So this is the same process as before. The diagram helps us visualize, figure out what shape, we add any labels, we find our equation. The only difference here is we're not solving for the V, we're solving for the H. So I do an extra step where I rearrange the equation into the new form that I need. So I needed to figure out the height, so I rearranged to get height by itself. Then I subbed and solved just like before, and then I concluded with units. As a final question, let's take a look at number 9. All right, for number 9, we are asked to determine the volume of the irregular solid shown to the right. So we have this weird blobby shape. We know the area of the base or the top, it's the same thing. is 24 centimeters squared, and we know the height is 15 centimeters. This illustrates the fact, or the formula for general prism. So this isn't a prism, but that's okay. I want to just talk about that for a moment. On the one formula sheet that I've posted, we see that volume equals the area of the base times the height. So volume equals area of the base area, times the height. And this is going to be true for any kind of regular shape like this. So if I want to find the volume of a cylinder, I've taken a circle and I've moved it down. I've extended it a certain amount of height. So I just took the shape and then I moved it down. How do I find the volume of a cylinder? I find the area of the circle and multiply by the height. Same if I have a triangular prism. I'm just taking that triangle and moving it down. So I would find the area of the triangle. Right here, let's just do that. So area of the circle times the height. Same thing here. I'd find the area of the triangle times the height. If I have a rectangular prism, I'm finding the area of the square and multiplying by the height. If I have a polygon of any kind, I find I'm always just taking the top shape, the top layer, or what we call the base height here, and moving it down and extending it. So this would be the area of my polygon times the height. So anytime I have a nice regular shape like this, where I've just started with some original shape and then extended it down, so my circle moves down, or my triangle moves down, or my square moves down, or my polygon moves down, the volume is always going to be the area of that base multiplied by how far I extended it, which we call the height. So in this case, I don't have a name for this shape. I don't have a special formula for this shape, but it's the exact same pattern that we've been using all along for all these kinds of extended shapes. So what do I know about the volume? It's the base area times the height. Do I know base area? Yes, it's 24 centimeters squared. Do I know the height? Yes, it's 15 centimeters. So 24 times 15 is 360. My units is centimeters, and its volume, so it's cubed. So the volume of this shape, despite not being able to name it and having a weird area or weird shape, that's fine. 360 centimeters cubed. Let's double check our answer key. Yes, 360 centimeters cubed. The point of this question is to illustrate this formula, and that you saw the stuff I just had written here. No matter what the shape is for the base, as long as we know the area and we see that the shape has been formed by just extending it down, this formula is always going to work. All right, once again, let me know if you have any follow-up questions to this homework, anything specific that was confusing or you need me to go over again. Otherwise, good luck and happy practice work.